Hello, everyone. Today we'll be looking at exploring the teaching of fractions from the conceptual to the procedural stage, where the primary school curriculum guide will be in focus. We'll be looking at every teaching point from Standard 2 to Standard 5 using the curriculum guide provided to us by the Ministry of Education. This section will focus on Standard 2. Let us begin with an overview of what the teacher is expected to cover in Standard 2. In Standard 2, you are expected to cover the basics of fraction. By this I mean you are supposed to link fractional application in everyday situation. You are supposed to know the fraction models. You are supposed to introduce fraction manipulators to the students. They are also to know parts and the whole, and they must be able to tessellate using the fraction manipulators. We will also look at naming fractions, comparing and ordering fractions, forming equivalent relationships, and comparing fractions using equivalent relationships. You need not to worry. I will simplify all of this for you. Let us begin with the basics. If Tom has marbles and he gives some to his friend, the number of marbles his friend has is part of the number of marbles Tom originally had. We therefore can say Tom now has a fraction of the original amount, and his friend also has a fraction of the original amount. If you were to look at this young lady walking, you can also walk a fraction of a distance. Additionally, if an artist is painting, he may be able to paint part of the drawing and not the whole. In this case, this also is a fraction. Upon inspection, the first case is a particular type of fraction model called the set model. Notice carefully, the young lady did not walk the whole distance. She walked part of the distance. Is therefore called the linear model. The other model spoken of, where half of the picture was painted, is called the area model. Now that the stage is set for the introduction of fraction manipulators, in this lesson, we will be looking mainly at the fraction wall. But some teachers may prefer using the fraction circles. However, teachers must know that they need to have their pupils spending sufficient time getting familiar with the manipulators. To facilitate this, teachers may introduce each piece in the fraction wall starting from the whole. Then, probing questions like how many halves are in the whole can be asked. This may be demonstrated as follows. The teacher will present the whole. After presenting the whole, he then presents the halves that are equal to the whole. Then he tessellates, or he matches the halves on the whole, ensuring that there are no spaces. Then a conclusion can come that there are two halves in a whole. This can then be repeated for all the other unit tiles in the fraction wall. Then you can proceed to asking higher order questions like how many eighths are there in one half? Again, this can be demonstrated by looking the half tiles, then tessellating with the amount of 8 tiles. From your observation, you will see that there are 4 eighths in one half. You can also ask a question like, how many sixths are equal to 2/3? Here are your 2/3. The students will then get the sixth tiles and match them and tessellate them with the 2/3 so that we can see that there are 4/6 in 2/3. Whenever you are teaching naming fractions, please do not tell the students where the fraction got its name from. Rather, you should help the students discover the link between the name and the number of equal parts in the whole to which the fraction was divided. Let us take a look at this fraction chart. This fraction chart can be used as a resource to help the students discover the link between the fraction name and the number of equal parts to which the whole was divided. You can ask some probing question like, how many equal halves are there in a whole? They can either take a look at the chart and discover it, or they can use the manipulatives for them to discover it. Following this, you can ask the question, how is a half represented? Then ask the question, what do you notice about the 2 digits that represent the number name? Then you can follow this question with, are there any similarities with the name and its representations? You do this for each and every one of the unit functions that are presented there and continue until they discover the relationship. Then you can ask, where do you think the fractions got its name from? Or perhaps you can ask some higher order questions like, what type of numbers do the fraction get their name from? This is a reasonable question to ask because they would have done ordinal numbers previously. So it is part of their schema. You can also ask the question, and this is for future reference, if a fraction tile were divided into 100 equal parts, what will be the fraction mean of each part? This obviously pointing towards percentage that will be tackled later on in the course. Now we have gotten to the stage where we can compare fractions. Teachers can draw on the students' previous knowledge to test for readiness to transition to this phase by simply asking them to compare 1 or 2 whole numbers. Remember, Buna advised us to revisit the curriculum periodically at a more sophisticated level at each time. Then we can now review the symbols and the meaning of each symbol. Here are the symbols that they were exposed to and their respective meanings. Having refreshed their minds on the symbols and the meaning, you are now ready to compare the fraction. This again should be done with the use of manipulatives. Take, for example, if we were to compare a half with a quarter, here is the fraction tile that represents a half. And here is the fraction tile that represents a quarter. We are now going to use the concept of overlapping or tessellation to determine either equality or whether it is greater than or less than. When I place the quarter tile on the half tile, I can see that a half is greater than a quarter. Looking at the reverse case, we can see the reverse is also true. That is to say, a quarter is less than a half. We can also compare multiple fractions with each other. Let us say we are comparing 2 quarters with a half. Here are 2 quarters. And we can see the 2 quarters tessellates snugly with a half. This tells us that 2 quarters is equivalent to a half. When teaching a concept lesson, it is important to teach non-examples as well. In this case, we are going to use a non-example of an equivalent relationship. Let us use the same quarter and a half. In our previous experience, we saw a quarter is not equal to a half. All these should be discovered by the students so that the students interact with the manipulators to enable them to determine whether a fraction is greater than, less than, equal to, or not equal to. Let us continue with the idea of equivalent relationships. And to do this, let us look at equivalent to a half. Teachers should fully explore equivalence along with their pupils by using tessellation. For example, you may ask the students the question, what fractions are equivalent to a half? The teacher would then use the half fraction tile, then say to the class, see how many fourths are equivalent to 1/2. The students would then look for the fourth tiles. Then they would investigate through tessellation to determine that there are 2/4 a half. This exercise can be repeated for the 8 tiles. This is because 8 is a multiple of 2. Subsequently, the teacher can then use the same fractions in the concrete experience and place them in a table looking like this. Then the pupils can then work out other equivalents using the same tessellation. They will also familiarize themselves with the use of the symbols that are used to compare the fraction. The pupils would also be familiarizing themselves with the use of the symbols that are used to compare fractions. Now, comparing two fractions is one of the prerequisite skills for ordering more than 2 fractions. Let us now turn our attention to writing a set of fractions as Sendic order. Take these for example. Remember, algorithms ought not to be used at this level, just the fraction tiles. Here are the 8 tiles, and here are the half tiles, and these are the quarter tiles. Now, what we will do, we are going to represent or model the fractions that are to be written in ascending order. Let us first start with the 5/8. Okay, this is 4/8, so let me take one more 8. All right. Now we have 5/8. Now we are going to juxtapose the half tiles to the 5/8 tiles, like this. And we are going to do the same for the 3/4 tiles. All right. Now all three fractions are represented. And from observation, you can see that 3/4 is larger than a half and 5/8. You can also see that a half is smaller than 5/8 and 3/4. To write this, therefore, in ascending order, it would be a half, followed by 5/8, followed by 3/4. Remember, writing any number, whether it be a fraction or whole number, in ascending order means you are going to start from the smallest and proceed to the largest. This is the end of the teaching of fraction for Standard 2. Stay tuned for the teaching of fractions in Standard 3. Please don't forget to like, share, and subscribe.